Okay, recording has started. Start sharing my screen. Okay, and hopefully that comes through now. All right, so just to start off with it, the code for today is on the screen now, before I forget. So for anyone watching later, that's what you need to take a look at. So we'll start off today by doing an example with exception handling, and then we will move on to the next topic, which is linked lists. And for exception handling, we'll do the sort of exceptions that we've done, or the kind of problems we encounter most often, which are normally range-based problems. So we'll have a inheritance-based system for defining what those errors are, and then we will catch and detect and throw with using those classes. So let's begin. I'm just going to put all the related exception handling classes in a single header file. The exception classes tend to be quite small, and they're very closely related to each other. So, and you can have a million different exception header files and CPP files if you really want, but I think this is one of those cases where they are so, let's call them errors, just to differentiate between ours and the built-in C++ exception class, although ours we would capitalize it, the standard library doesn't. But let's just call them errors to avoid that problem altogether. All right. Okay, and a CPP file to implement them. Typically, it'll just be marshalling data that you might want in the error handler around. Not really much processing will happen here, so shouldn't be that complicated. All right, so not example.cpp. I could have renamed it, I suppose. Okie dokie, and link to the header file, as we normally do. Let's see if there's any initial questions. I've already said that what we're doing today, we're going to do exception handling and example, like we said yesterday. Remember at the end of class we looked at the slides, but we needed to do an example. And then we will look at linked lists. So we're just finishing off where we got to what we looked at last time with exception handling, except we'll do an example now. All right, so let's take a look. We will have a family of related classes that define these errors and how they relate to each other. So let's create a broad general error class, which will refer to any kind of error, and maybe the only thing we could really speak about such an error would be its a message that we pass along. The C++ exception class is like that because it has that what function which will retrieve a string message that you declare. So we'll do something similar here. We will create a nice protected string to represent our message, and we will bring that in from the string library and store it there. So all we will need here is a default constructor and one where we specify the message. But we don't need a destructor because the string will handle itself. There's no manual allocation and deallocation of memory by our class. So that's all there really is for that. So all we need is simple. Oh no, I put this in the CPP file when I'm meant to put it in the header file. And all we will do is set a default. Not even going to worry too much about default message as a class constant. I'll just set it here. Roll error. And here we will simply specify what we want the message to be as string message. Okay, doesn't really matter, but all right, so here we go. That's the basic kind of error. And then we'll say, as a particular kind of error, we will say that range errors are a more specific kind of error than simply just an error. So we'll create for ourselves a range error function, which or class, which will be a kind of error. So, and we will have constructors for it as before. We should also have a get message function to retrieve our error message so that it can be displayed or whatever people want to do with it. We won't have to re-specify this in the derived classes, of course, because they'll be inherited. So we'll only need to specify the information that's specific to that error. So actually, yeah, we could rather calling it a range error. We could call it, let's say, a value error, and we could say that minimum range errors and maximum range errors are kinds of value errors. So here we will retrieve the message. Inside the value error, we will introduce the concept of the value that's being tracked. We could make this templated, I suppose, that we can store any kind of value as a potential problem, but that's probably going a bit too extravagant. So we'll store it as a double, which is fairly general. And we will have a double representing the value itself. And we will have similar constructor for default, but we will now also have a fully parameterized one where we specify both the message as well as the value we want to indicate. So and a double for the value. Okay, I'm just going to define the class hierarchy in its entirety first, and we can implement all the functions. So it'll be quite straightforward. This will need a get value function. And then we will say that minimum range errors and maximum range errors are kinds of value error. And each one will introduce a min value in addition to the regular value and a max value in addition to the regular value. So they'll all specify increasingly more details about the kind of error that's occurred. So this is a kind of value error. Okay, be pretty similar. Some editing. What we're going to be specifying here is not just the value, but also the minimum, whatever that might be. And this will get the minimum. And we will need to store the minimum in addition to anything else. And we can create a max range error, same story, except we specify the maximum that we've exceeded. Okay, so let's now implement these. So what did we have so far? We just had the regular error. So let's introduce the value error and its functions. Did I leave out a semicolon there? No, I just didn't copy it. The min and the max. Okay, let's fully parameterize these and get ready to implement them. So this is the regular value error. Okay, same story for the parameterized one. Accessor. And this one will be the min range error. And this one will be the max range error. Okay, so I'm going to be monitoring Discord at the moment, but I will check to see if there's any further questions here. Yeah, I saw that. Thanks. I only noticed later. And then did I misspelled errors somewhere? I might have. Errors. We will see if I have corrected that or not. The compiler will tell us, or we'll see in a moment. Max range error, the max. And the max. Incredibly simple. The whole idea is you don't really solve the problem in the exception class itself. You simply signal to the person who's using your data structure, and they can then do whatever it is they want to do with that knowledge, which can be nothing, it can be reported. It's their choice what to do. You're giving that control back to the client programmer and not making a decision to, let's say, end the program on their behalf. They might think it's not so bad if something is out of range in this case. Maybe worth logging, but not worth ending the program over. Right, so let's quickly hustle all this up. Right, so the value error here, we will simply chain upwards to our regular error class and specify that this was a value error. And we will then must also set the value to some reasonable default. So in this case, I'm going to set it to null. Null, I mean 0. In this case, what have we got? We're now sending all the information. We're sending the message up. This is just another good exercise in. We can send the message up, or we can send it sideways. It doesn't really matter. But if we set it sideways, then we'll be setting this to 0 and then setting it to another value afterwards. So I'm going to send it up. So up to error, and then give the details, which in that case will be str message. And then we will set value equal to whatever it is. Value equal to dbl value. Accessor will simply return it. For the min range error, we can cast upwards, and we will cast up to error. We can cast up to value error now quite safely, and we can say or chain rather, chain upwards, and we can set this is a min range error, and the value involved 0, and the min, since we're not specifying, is also going to be 0 here. Hopefully we'll specify everything, but we're just creating no args ones because it's to provide some defaults. And then over here, the more qualified one. Let's think about this here. We're only specifying the min. We also need to specify the value as well. So it's not replacing it. It should be augmenting it, which I did do in the interface. Up. Okay. So we can chain upwards again, passing the message and the value. So to value error, pass the message, and DBL value. And then internally, we will handle the min. And then in the accessor, we will return it. And then for max, it's the same story. Okay, I'm going to have to fix this then as well. And we will chain up to value error. Say this is a max value error, pass 0. And here again, chain up to value, set the message, pass the message up, as well as the value, and then internally set the max to the incoming max. Sure, I did that, yeah. And return over here. Return max. So now we've got our accessors, mutators. We've done a bit of, no mutators, sorry, but accessors and constructors with chaining up through the inheritance thing, so a bit of revision there, as well as over here, we can just see that we've got a broad kind of error. All we can really say about it is that there's some sort of message. Here we've got a more specific kind of error. We know there's a value involved, so we store that value and provide access to it. Now we can actually say, actually, it's a more particular kind of error with a value is the error that there was a range and that there was a minimum as well as the value. So we specify all those extra bits of information, namely the minimum, and pass everything else up, and same for the maximum, and pass everything else up. So now we've got our family of error types related to each other, and we can use them. So let's just create a very simple class that will have the possibility of some sort of errors involved. So let's say, for example, let's make it a collection. Yeah, okay. .h. Squeeze in a bit of revision, there's no harm. Except this will make use of these error functions. In fact, what we could even do here is we could define our enforce range function as a function in this library, enforce range, rather than build it into our data type itself, because range checks are fairly general. And we will have our DBL value, DBL min, DBL max, and then we can even specify the message if in case this is violated over here. So this would actually have very minimal impact on our collection itself. The fact that it's using exceptions won't really need to heavily impact our data structure. It's just that the error handling that we've added separately will wind up throwing those exceptions. So the impact is actually fairly low. So let's do it that way. Okay, and we can implement our error handling code just like we did before, except instead of exiting with a status code defined in an enumeration, we'll simply throw the appropriate kind of error. So as before, we say if our value is less than our min. That's clearly a min range exception. So we will throw a min range exception. So throw new min range error, and we will pass the value as well as the min, as well as the message. Let's just check the order in which we said that. So it was message first, then value, then min. Okay, fine. Let's say oh no, we don't even need to make up the message. It's coming through as a parameter, so the user can, or the client programmer can sort that out. And same story as well, if dbl value is greater than dbl max, then throw max range error with the message and the value and the max. Tell us how we violated it, and all of this in a very general way. It's not tied to a specific data structure. It can be any message, any min and max that's involved, any value. So it's fairly reusable. So if we had a family of different things, which are unrelated classes even, that could be throwing errors, we could reuse this function in all of them. And as you see inside the collection, which will just make a simple container of, let's say, integers, it won't need to deal with those problems. It won't even really be, need to be changed from a regular one as before. It will just start raising exceptions normally. So let's do that. If find collection H. Okay, and we'll just make it a very simple container of integers. And yeah, just a simple one-dimensional container of data. And why not have some provision here? We can have a copy constructor because we will need a destructor to delete this data at the end. We need a constructor that will allow us to specify the length. We will need, let's say, a destructor, we said. And let's keep it nine. Let's keep it. Let's get. I mean, let's have some good revision in here. Let's also put in an assignment operator, which we'll need to anyway, because we have a destructor and a copy constructor. So if you have any one of those three, you need all three. So let's have our assignment operator. And then for modifying it, let's just have a indexing operator. Incoming index. And it could modify it, so that's not going to be const. And then a length accessor. I think that's all we really need for a very simple container. So let's implement all that. Let's have some help functions. So let's have a setup collection function where we specify the length. Let's have a deallocation function. We will delete. And we don't need to do enforce range because that's already built in. We can do a clone copy collection. We've got that in the constructor. So this will be a good revision of original. And for any other kind of error we haven't defined yet, I'll throw exceptions, but we could, of course, always, I'll just throw the base error type, but we could, of course, always add new classes to this, rich hierarchy describing the kinds of errors that can occur. So for anything that's not a value error or a min-max or whatever, I will just throw a normal exception, but we'll use exception handling in this type. So let's implement this. Okay, link to our header file. Oh, I didn't do any defaults. Let's do that. I mean, max, min, and so on. Let's do that over here. So we'll have a length. Let's say it must be at least 1. Maximum length. Number. There is a library called limits where you can get the numeric limits for various types, but we won't worry about that. And then a default length, let's say 10. Okay, let's start implementing or fully parameterizing. Helper functions first, since they will make the other stuff much easier. And also, if we redirect most of the functionality to those, then we can test for the errors in fewer places. Okay. Okay, and then the actual most of the work will be done here. Oops. These functions. And copy. Right, here we go. So let's do our setup. So we assume that length is going to be at least min length, between min length and max length. So we can call our enforce range function, which is now inside errors.h. So let's call it enforce range. We've got our length, and it must be between min length and max length. And we needed an error message. So that first, let's just check. For whatever reason, I put that at the end there and at the beginning in the classes themselves. That was a bit inconsistent, but we'll just live with that for now. And then we can just say invalid length, invalid length. Okay, so that will handle that. Now we can safely create section. So, and initialize it to 0, let's say. And here we go. So that's our creation function done. Our destruction function will be very easy. There's nothing to really check here. We simply delete the one-dimensional array. So that's it. And then for copying, well, there's an assumption here that the values are the same. So I'm going to enforce that. I think in the tutorial today I used insertion to do it, but let's use the manual exception handling to deal with that. We don't have a specific exception type for it, so I'm just going to raise a normal error. But let's just say if my length is not the same as object original's length, then we have a problem. So I'm going to throw an error, and I'll specify the message as being size not identical, size not same as original. Okay, and then after that, we know that the sizes are the same, because remember, as soon as you hit a throw, it will stop and go back and try and find the exception handler code in the catch blocks. So we can now write code as if the error hadn't occurred, because it'll reach that point in the flow of control if the error had occurred. And we will simply loop over our length, which we know is the same as the other's length, and transfer into our data the original's data at that position. Okay, so that's that done. So for our destructor, we can simply call free collection, get length. It's easy. We can simply return length. And over here, look at let's just do the setup. So here we will just set up collection with default length. I'm not going to worry too much about delegating this stuff around. We did it before. Int length. Oh yeah, I would delegate 2 here, not away from there. So if I want it to be consistent, do it like that. Structured delegation, not regular delegation. Over here, same story. First thing is we make ourselves the same size, and then we can do the copy safely. Then on the inside, we can safely call copy collection and pass the right-hand side to it, so we can make a copy of the original. So all of this is very simple because of the helper functions. And then in the assignment operator, all we need to do is to check for self-assignment. So if we are not the same as the right-hand side, then we have work to do, otherwise we're done. So if we're done, we can simply return ourselves dereferenced, because this is a pointer and we're returning a reference, not a pointer. And then the things we have to do if we're not the same is we have to first free existing state, then make ourselves the same size as the right-hand side, then copy the right-hand side's contents plus, and we are done. So now we've got an exception handled one. I think we still had to do indexing because that's going to involve tests. Yeah, there we go. So now we can check to see if this index is in range. So we can basically say enforce range by checking the index, making sure it's between 0 and the maximum valid index, which is length -1, and then the message if that doesn't happen. But really the last parameter, was it the first? I did this before. No, you should be at the end. Yep. And yeah, so we can just say invalid index. And then safely return value inside data at that position. So now we've got a safe collection type. Let's just use it very simply. We can manually trigger some errors. So let's do a main. I do have a main. Let's make use of it. So let's bring in our collection. It should automatically bring in the error handling. No, it doesn't. So we did that in the CPP file. So let's manually bring it in here. Hash include errors. And now we must make use of our type. So we're going to specify which region of code the errors can occur in. That's pretty much all we're going to do. So basically, our try block will have all the interesting code in it that's not error handling. So first things first is let's try and create a collection. We'll do it properly first just to make sure everything's working. Okay, just store some values in it, and we'll mess with the code to break the or to trigger certain errors. So object stuff at position I, that's be equal to let's just store I in there. That's fine, or I+1, whatever. So this is the stuff that could go wrong. I think that's good enough for now. Then we will catch certain kinds of errors. So we must catch errors in the order of most specific to most general. So the most specific kinds of errors are the two specialized max and min range errors. Doesn't matter the order you catch them in, because they're both at the same level in the inheritance hierarchy. So I'm going to catch a max range error. You typically catch them by reference often because you might need polymorphism or whatever, but we're not using any polymorphism. But it's very common to catch these by reference. And we're not actually going to do anything. We're just going to output to the error stream that we caught a range error and output the message. Did I make an access of it? Yeah, I'm not sure why the code completion isn't getting me, but hopefully we'll not have any problems with that. Also output the value space or something and min. Okay. All right, so we're not going to do anything with it, but at least we're reporting the error in a more detailed way. So we can catch our max range errors, catch our min range errors, same story. Oh, that's why it wasn't get max. Okay, fine, we'll catch max first. Sorry, my bad. Get max. Min. And then have we thrown any other kinds of errors? I think we might have thrown the copying error as if there was an error. So we'll catch the general error type. Strange error. There's not much detail we can really say about that apart from the message. So we'll leave that out. And then worst case scenario, catch something else, something we completely didn't expect that isn't even related to any of our error types. So what we do then is we can error output an error message, so why the failure, and then that's all we have to do with that. So this should be okay. Let me just check if there's any questions, and I'll compile it and debug whatever debugging related error mistakes I might have made. All right, so okay, so this looks like a long way of handling errors. So it is more work, that's why it's bonus, but it does give control back to the person who's using the codes, the person who's writing main. Remember, the assumption isn't that the person who's writing the data structure is going to be the same person who's writing main. So it isn't really good that the person who's writing the data structure makes decisions that affects the person who's writing main. So this way they give control back to the person who's using the data structure so that they can make their own decisions. But it is more effort, and that's why it is a bonus. And it is the standard way to handle errors in libraries, because the person who's writing the library or the framework or whatever isn't you. They're trying to make their stuff available for other developers to use so they can give the control back to you. No, it wasn't meaningless to the user, but the assumption then for the exiting with error codes is still incredibly common, but it does mean that the program is now stopped, which may be perfectly fine. But the person who uses a library that then exits with error codes means that if a problem happens, their program is going to terminate, and there's nothing they can do about that. If they're okay with that, that's not a problem, whereas this gives control back to the programmer who's using it. The form for remote application was sent out yesterday. You need to check your emails. It was sent out via the email address you have associated with you for Blackboard. So if you're not receiving Blackboard emails, that's a big problem, and you need to follow up on that. So check your email, check your spam. If you haven't found it, then contact me, but it means you've been missing out on a lot of information from a lot of subjects. It'll still be bonus in semester test 2, just like it was last year, so it's optional to you. That's an excellent question, the difference between a return and a throw. So a return is a normal mechanism for returning a value. Throw won't necessarily go up one level, right? So here we're throwing, and we'll be caught in main, which is one level up. But we could have called another function that called another function that called another function. In fact, over here, when we do this, it goes into collection, and then into enforce range, and then only in enforce range does the value get thrown. So the flow of control will be, here the error is found, the stack unwinds and deletes this function from the stack, and then deletes this from the stack, and then finds the catch block in main, which actually handles the error. So it does a lot more searching to find a catch block than you would for return. Return simply returns value one level up. But this is very expensive, this mechanism. That's why it's not always on. You have to turn it on manually, and its purpose is to signal errors, not to return normal values. So you must never use throws for passing information around your program for anything other than an error. Its purpose is for error handling. So that was an excellent question. Yeah, bonus marks, you're correct. There'll be a memo for Prac 8 after it's finished, so you're not going to get anything about that beforehand. No. So you must read the question and interpret it and do your best. That's all there is. You've got a complete mark sheet. If you've done it differently, then you will still get marks according to the mark sheet. But yeah, that's what programming is. Your job isn't just to replicate things exactly the same as a video you've seen. Your job is to read the problem and solve the problem. So why does it return a collection reference instead of just a collection? To prevent an unnecessary extra copy, because if we return just a collection, it will run the copy constructor again, although technically these days with C++'s move semantics being smarter, it'll probably avoid the copy through copy elision, so it might not 100% be necessary anymore to return it as a collection reference, but that is still the standard. If I forgot the tilde, let me find it. I didn't, but maybe it's another one. The compiler will tell us, so yeah, I'll keep my eyes out for that. Yes, the code will be uploaded. All right, that's why these videos are made available. You can rewatch them as often as you need to be. Again, this was sent out to you via a mass email. If you're not receiving your emails from Blackboard, contact me, but then you've got a big problem. And the link will be there under announcements on BB anyway, so check that. So yes, you can have handwritten notes. That's not a problem. Nothing that will allow you to copy and paste, but handwritten notes not an issue at all. Yeah, so that's that. Remember, if you're writing remotely, you have to apply, and then it is via Proctorio. There's no option about it. All right, let's see if we can find our errors in the time we've got left. K is unhappy here. Oops, I think I've got too many. Too many brackets, so that bracket is not needed. Solve view. I. What is I? Oh, int index. I meant int index. Okay, let's try again. Missing semicolon. That's fine. Compile again. Okay. So this should work fine because we aren't doing anything weird or wrong at the moment. So we should just see the numbers. Actually, we won't see anything at the moment. We're not actually doing anything. So let's, well, it's super useful. We're just testing the error handling. So all we're going to do is immediately output obj stuff position I with a space between it. And then at the end, we'll output an end of line. Okay, let's try again. Okay, so we should just see the numbers 1 to 5. Okay, perfect. Now let's make a mistake. Let's say, oh, we accidentally did the negative index. We should now get a range error, a min range error being triggered. So let's see if that occurs. And you can see our error handler runs, and it says it caught a, oh, don't know why it says max range error. Is that am I throwing the wrong ones? Because that looks to me like it's a min range error, or I passed my parameters around the wrong way. Let's just test that again by, let's say, massively making this too big. Yeah, I've clearly got my things the wrong way around somewhere. So let's just check that out. Let's check inside here. Am I throwing the right ones? If you're too small, min range error, that's correct. If you're too big, max range error, that's correct. Inside main, catch max range, output, yeah, sorry, max, inside min range, min. Okay, so that should be fine now. So now we should get a min range error over there, which is perfectly good. And the details about it being an invalid index and all of those things, that's wonderful. Likewise over here, if we triggered it here, we would get an index, an error, but it wouldn't be about the index. So caught a min range error, invalid length. I don't know how useful this spacing is like that, but the basic idea is sound. So now we've got a collection type that is protected by exception handling. We give control back to the person writing main to decide what to do with stuff. Just to check with this weird one over here, let's say we threw something that wasn't related to our exception family. Let's say, for example, over here, let's say instead of throwing a proper enforce range thing, just do the error manually even. Main, just for demo purposes. Let's say the code somewhere did something weird like throw true. It's legal in C++ because true is, you can throw anything, but we don't have a catch block that's compatible with true or anything related to true. So this one will trigger. So if we do that, no, so we're still triggering our old error. Let's fix that. Now we will reach this line of code, true will be thrown, and then this one should be caught, the general case. And you can see that's exactly what happened. So that's exception handling with quite a comprehensive example. We also revised some operator overloading as well as constructors, destructors, inheritance. So there's quite a lot of revision in that bit of work. I will upload the code for this, and then on Friday we'll start with the next section. See if there's any further questions. No, okay, so in some programming language, negative indices are meaningful. So you get the stuff from the end of the collection when you pass a negative index. In C++, that's not meaningful, so should be treated as an error. So just do bear that in mind. Yeah, I've made several mistakes. Hopefully I fixed them now. It seems to be working correctly. And this type of exception handling will be bonus. Yes, it'll be bonus like last year. So that's perfectly correct. All right, so that's exception handling in more detail than you needed. To be honest, you don't need such big exception handling classes. If you take a look at my file handling code from last week, what you often do is, if you don't care about passing messages around and stuff, let's say we just had a problem class, and then a value problem, or like a range problem, whatever, is a public problem, and so on. And you don't actually need to put any data inside it. All you're using is their relationship to each other in the catches. That'll work fine. So you don't necessarily have to go as detailed as this with, you know, extra information being added at each level like we've done here, but that was also just to help demo or remind us about inheritance and adding information in the derived classes. All right, I think that's that. So I'm going to stop recording. I wish you all a good evening. I will upload the code now, and the videos, obviously, only once they're indexed will be available. We did the code at the beginning, so all is well. Okay, goodbye.